This is a hole in the countertop in my pop-up camper where a faucet used to be, and this is the faucet I intend to mount in its place. But it obviously isn't going to go there without some kind of mounting plate to cover the hole. But as you can see, the hole is big and irregular, so how do I get a mounting plate? In theory, I could have made it from metal or wood, but 3D printing seemed like the best choice because then I could fill the hole and make a stiffer plate that held the faucet better. So that's what I did. But I had zero experience with actually building 3D models. So where did the design come from? I tried finding an existing design on Thingiverse, which had always worked for my little 3D printing projects before. There were indeed dozens of mounting plate designs, but none of them were the hole-filling one I wanted. Could I learn enough 3D modeling to design it myself? Sure, given enough time, but I wanted it now. So I basically cheated. Let me explain my 3D printing process as simply as I can, starting at the end and working backward. My 3D printer needs a G-code file that tells the printer step by step where to move and where to extrude the filament. The G-code file is the output of a slicer program, whose input is an STL file that describes the surfaces of the things to be printed. You can preview how the print is going to be built up layer by layer. The STL file has to be generated by a 3D modeling program. I picked OpenSCAD, which is free. If you know how to use it, you can construct a 3D model from scratch. I don't. So this is where the cheating came in. I asked Google's Gemini AI agent to do it instead, using some rough measurements I made on the hole. I gave it a prompt, something like, generate SCAD code for a mounting plate 115 millimeters square and 8 millimeters thick, with the corners rounded at a 10 millimeter radius. Add a 4.9 millimeter screw hole, inset 10 millimeters from each corner. Then add a cylinder 88 millimeters in diameter and 15 millimeters thick, centered on the bottom of the plate with a 20 millimeter vertical hole through the center of the entire assembly. And lo and behold, it cranked out a series of SCAD instructions to model that, and very nicely made all the parameters variable. OpenSCAD took those instructions, generated the STL file for the slicer, which output the G-code, which the printer then turned into this mounting plate. I was a little off on some dimensions due to sloppy measurements and some shrinkage, so I had to do it all a second time. But the end result was just what I needed.